Hello and welcome to episode 4C of Multivariable Physics. So this is this is going to be the last bit, I think, on the derivative, and we're going to move on to using it. So I already talked about the chain rule. Now we're going to talk about actually doing. So we're going to talk about also higher order derivatives. So this one thing we need to realize here, right, with multivariable functions is that, we can have a function f of x, y, right, and then we can go and you can take, okay, partial x of f. It's going to give us something, right? Or we could have done partial f over partial y, right? And that's going to give us something, right? We don't know what it is. But this is going to give us, but this function, let's say it's g, it's going to be a function of x and y, right? So we can also just take, partial dx of g, or we could take partial of y of g, right? We don't have to take x twice. So we actually have a few different combinations, right? So this is actually going to be f of x squared, partial squared, but this is actually going to be partial squared f over partial y, partial x, right? So we actually have a few different ways to take these. So we have f of x of x, f of x of y, f of y of x, and f of y, y. So we have 4 different combinations, and we're actually going to see this is actually 3 because these are the same. But if we actually had 3 different variables, okay, we have x, f, x, y, y, f, y, x, z. We have more and more and more and more the more variables we have. So we have a lot of different combinations of these things. So one thing we want to think about is that how can we reduce these? And so long as there's a nice theorem we can use here, and so long as f x, y has continuous partial derivatives, so continuous partial derivatives over x and over the domains of x and y, right? Then f of x and x, f of x y is equal to f of y x. So this is called equality of mixed partials. Hope all that makes sense, right? So I'm going to look at just thinking of something. What happens if there's this interesting case here where we can take, let's look at this function here, f equals k, and so this is going to lead into this thing that I didn't even talk about called Laplacian. So we already talked about, we talked about mixed partials and higher derivatives, right? Just different combinations of these things. But now we're going to talk about this thing called Laplacian. So let's suppose we had this function. We just get a bigger pen and scribble through over some of this. So we had e to the power kx cosine y, ky. Well, what's going to happen if we take, okay, let's think about f of x. Well, this is going to be k squared. This is going to be k squared ekx cosine ky, just because of how this works. F of yy, well, this is going to be negative k squared cosine ky, because obviously second, if you don't know why, that's because if you take the derivative of cosine twice, you just get negative cosine, and since you have the k, we pop that in. So you have this interesting thing, arrangement where f of x is equal to f of y, or f of x plus f of y is equal to the negative, is equal to 0. So this is called Laplace's equation. I am bad at this. So Laplace's equation, and it can be represented through this thing called the Laplacian. Nabla squared of f. And this is going to cut into, if you remember what I mentioned earlier, that nabla is a vector, or we can think of it as a vector, you know? So what is nabla squared? Well, that's just, well, nabla squared is nabla dot nabla, right? Which is going to be d over dx squared plus y squared, you know, equals nabla squared, right, for however many dimensions. And if we take f and we just apply that, we just apply f to each of these. So that's f, right? And so Laplace's equations, when the Laplacian of f is equal to 0. That's all that means. And so this is handy when you're dealing with, you know, waves and periodic things, like with trigonometric and stuff like that. This does show up. So I just wanted to briefly touch on that aspect of everything. And I think that's going to be it for this episode. It's a very short one. Yeah, so now we can actually move into episode 5. I'm going to head into episode 5 now. And that's just going to be about tangent lines and things like that. So see you then.